Today on the Mankind Atlas, we will deconstruct the most significant strategic vulnerability of the modern age. We will move beyond the headlines of territorial disputes to expose a silent technological war where power is measured in nanometers rather than missiles. In this investigation, we will reveal the hidden mechanics of global dependency and explain why the entire architecture of the 21st century economy will hinge on the stability of a single geographic point. We will confront the reality of our absolute reliance on a fragile silicon foundation and examine the microscopic power struggle that dictates the survival of our modern global infrastructure. Let's begin. Imagine a world where your smartphone is nothing more than a glass brick, where your car won't start, your hospital's MRI machines go dark, and the global financial system freezes in an instant. This isn't the plot of a post-apocalyptic movie. This is the reality of a world without a single 13,000 square mile island. Welcome to Taiwan. To most, it's a vibrant democracy in the shadow of a superpower, but to the global economy, it is the Silicon Shield. It is the single point of failure in the most complex supply chain ever built by mankind. To understand how we got here, we must look back to 1987. At the time, the world of computing was fragmented. Companies like Intel and Texas Instruments designed and manufactured their own chips. But a man named Morris Chang had a radical, almost crazy idea. Chang realized that the cost of building factories, known as fabs, was becoming astronomically high. He proposed a company that would not design its own products, but instead act as a foundry for everyone else. This was the birth of TSMC, Taiwan Semiconductor Manufacturing Company. At first, the industry laughed. Why would anyone trust a third party with their most secret designs? But as the nodes got smaller and the physics got harder, the world realized Chang was right. No single company could afford the R&D alone. Today, TSMC doesn't just lead the market, it is the market. Why can't the US or China just build another TSMC? The answer lies in a process so difficult it borders on science fiction. Extreme Ultraviolet Lithography, or EUV. To print circuits just a few nanometers wide, thousands of times thinner than a human hair, TSMC uses machines from a Dutch company called ASML. These machines cost $200 million each and are the most complex instruments ever created. Inside these machines, a laser hits a drop of molten tin 50,000 times per second to create a specific wavelength of light. This light is then reflected by mirrors so flat that if they were the size of Germany, the highest bump would be less than a millimeter high. Taiwan didn't just buy these machines. They mastered the ecosystem of using them. A single fab costs $20 billion to build, more than an aircraft carrier. It requires a stable power grid, massive amounts of ultra-pure water, and a workforce of thousands of PhD engineers who treat chip-making like a religion. Numbers don't lie. Taiwan produces over 60% of the world's total semiconductors, and over 90% of the most advanced ones. The chips used in AI, F-35 fighter jets, and the latest iPhones. If Taiwan's production were to stop today, global GDP would drop by an estimated $10 trillion. For context, that is more than the combined impact of the 2008 financial crisis and the COVID-19 pandemic. Modern life is built on sand, specifically silicon sand processed in Taiwan. From the smart grid that manages your city's electricity to the sensors in your car's brakes, the world is effectively locked in to this one island. This is the definition of a strategic bottleneck. For decades, Taiwan has lived under the threat of invasion, but it possesses a weapon more powerful than any missile, the Silicon Shield. This theory suggests that Taiwan is too important to the global economy for China to attack, and too vital for the United States to lose. If Beijing were to seize the fabs, they wouldn't just be taking territory, they would be taking the brain of the modern world. But there's a catch. These factories are incredibly fragile. A single stray shell, or even a sudden loss of power, could ruin the delicate machinery inside. This creates a mutually assured destruction for the digital age. If the fabs go dark, China's own economy, which relies heavily on these chips, collapses alongside the West. In 2026, the demand for computing power has reached a fever pitch. We are no longer just building smartphones, we are building artificial minds. Generative AI, autonomous drones, and real-time global surveillance systems all share one thing in common. They are born in Taiwan. Companies like NVIDIA, AMD, and Apple design the blueprints, but TSMC is the only one capable of printing them. As AI models become larger and more complex, the world's reliance on Taiwan has shifted from significant to absolute. The competition for 2 nanometer and 1 nanometer nodes is the new space race. Whoever controls the production of these master chips controls the future of intelligence itself. It's not just geopolitics that threatens the supply chain. Taiwan sits on the Pacific Ring of Fire. Earthquakes are a constant reality. While TSMC's buildings are engineered to withstand such shocks, the precision required is so high that even a microscopic tremor can ruin a batch of wafers. Water is another silent enemy. Making chips requires millions of gallons of ultra-pure water every single day. During droughts, the government is forced to choose between diverting water to farmers or to the chip factories. If the taps run dry, the digital world stops breathing. Realizing their dangerous dependence, global powers are racing to reshore chip production. Washington passed the CHIPS Act, pouring billions into factories in Arizona and Ohio. Europe is doing the same in Germany. But building a factory is not the same as building an ecosystem. In Taiwan, TSMC benefits from a clustered supply chain. If a machine breaks, the engineer is 30 minutes away. In Arizona, that same engineer might be a 14-hour flight away. The work culture, the supply of chemicals, and the concentration of talent cannot be simply exported. This talent density is the real moat that protects the island from being replaced. Let's look at a black swan scenario. If a total naval blockade were to start tomorrow, the clock starts ticking for modern civilization. Within 48 hours, global stock markets would face a sell-off unlike anything in history. High-tech stocks, Apple, NVIDIA, Microsoft, would lose trillions in value instantly. By week 2, the automotive industry would grind to a halt. Without Taiwan's high-end servers, the digital infrastructure of the 21st century would begin to decay within months. This is why many analysts call a Taiwan conflict a civilization-ending event. For decades, Intel was the king of silicon, but they made a fatal strategic error. They were an integrated device manufacturer, IDM. They designed their own chips and made them in their own factories. This worked until the physics of the atom became too expensive for one company to handle. TSMC, by contrast, focused only on manufacturing. By taking orders from everyone simultaneously, they pooled the world's R&D budget into a single production line. Samsung tried to chase them, but as a direct competitor to its customers, trust was lacking. TSMC's motto, "We do not compete with our customers," became their greatest advantage. The real secret of Taiwan is the people. Working at a TSMC fab isn't a 9-to-5 job. It is a high-stakes military operation. Engineers carry pagers 24/7, ready to return to the cleanroom at 3 a.m. This culture of extreme precision and collective sacrifice is something Western factories struggle to replicate. In Arizona, workers demand work-life balance. In Taiwan, they demand perfection. This talent density is the real barrier to entry. Beijing has poured over $150 billion into domestic chip production through its Big Fund. They have hired thousands of Taiwanese engineers and attempted to reverse engineer Western tech, but they have hit a ceiling. Without access to ASML's EUV machines, which are banned for export to China, it is physically impossible to produce the 3-nanometer chips required for advanced AI. China is becoming a master of legacy chips, the ones used in washing machines and cars, but they are being locked out of the future. This technological containment creates a dangerous incentive. If China cannot build the future, they may try to take it by force. The clash of civilizations is happening in the cleanrooms of Phoenix. American workers, accustomed to strong labor laws, have struggled with the military-style management of Taiwanese engineers. In Taiwan, a technician is ready to fix a machine at 4 a.m. In Arizona, that requires a union negotiation. This cultural friction reveals a hard truth. Money can build the walls, but it cannot easily train the souls to the level of precision required by modern silicon. While the world focuses on Taiwan and China, the true emperor of silicon sits quietly in the Netherlands. ASML is the only company on Earth that can build EUV machines. Without Europe, Taiwan cannot produce, China cannot catch up, and America cannot return to power. The EU Chips Act aims to double Europe's share to 20% by 2030. They don't just want to make the chips. They control the machines that make the chips. This gives Brussels a diplomatic kill switch that is often overlooked. While the US restricts 3-nanometer superchips, Beijing is dominating the legacy chips. These are the older chips found in cars and medical devices. China is building more of these factories than the rest of the world combined. If China controls the supply of legacy chips, they can hold the global manufacturing sector hostage. You don't need a superchip to stop a Ford assembly line. You just need to cut off the supply of basic sensor chips. This is the underwater mine of the Silicon War. We are approaching the physical limit of silicon. Atoms cannot be shrunk forever. The next decade will see a shift toward more than Moore technologies like silicon photonics and 2D materials like graphene. This leap could reset the global leaderboard. If a new material replaces silicon, Taiwan's dominance might fade, but only if another nation masters mass production first. The race is no longer just about printing the smallest circuit, but about redefining what a computer is made of. The silicon chip is the invisible god of the 21st century. It manages our money, guides our planes, and connects our hearts. But this god resides on a small island, surrounded by rough seas and geopolitical storms. The Mankind Atlas is currently pinned to Taiwan. Whether through cooperation or conflict, how we handle this dependency will determine if the 21st century is remembered as an age of enlightenment or as the Great Digital Dark Age. The choices made in Washington, Beijing, Brussels, and Taipei over the next few years will echo for centuries. The conclusion is not a matter of sentiment, but of structural reality. Taiwan's dominance in the semiconductor industry is not a historical accident that can be easily replicated. It is a specialized convergence of talent, capital, and infrastructure that has no current substitute. While nations invest billions into domestic fabrication, the lead time for these projects is measured in decades, not years. This creates a period of unprecedented strategic vulnerability for the global economy. If the supply from this island were to cease, we would not simply face a recession. We would witness a total technological regression. Every sector, from financial markets to national defense, is structurally dependent on a few square kilometers of land in the Pacific. This is the central paradox of the 21st century. A world of limitless digital expansion built upon a single physical point of failure. The stability of the next decade does not depend on political rhetoric, but on the cold management of this absolute dependency. The silicon shield remains the most critical strategic asset on the planet, and how it is handled will determine the survival of the current world order. Thank you for watching. If you enjoyed this analysis, don't forget to subscribe, like the video, and click the notification bell if you want to see more deep dives like this. I wish you very informative days, and remember, latet enim veritas, sed nihil pretiosius veritate.